Hi everyone, this video will cover the basic ideas of describing motion which are needed for A-level physics. That is displacement time graphs, velocity time graphs and acceleration. So you should be familiar with these ideas from GCSE physics, but they are fundamental to understanding the more complex ideas that you need at A-level. Enjoy the video. So we're going to go through some GCSE basic ideas. And hopefully you're all very familiar with speed is equal to distance over time. This is a very typical formula from even year 9 and certainly GCSE. And the units you would have used at GCSE would be m over s, meters per second. And we need to get into the habit of using ms to the minus 1. So these two are equivalent, but this is a better way of writing it. Anything raised to the power of minus 1 just means divided by that. So ms to the minus 1 is meters per second. Other key ideas which you would have come across before, the ideas of vector and scalar. So velocity is a vector, it's got a magnitude, that means a size and the direction, whereas speed is a scalar, it's only got a size. So velocity and speed are quite interchangeable, even though sometimes the numbers are totally different. Very often the velocity will be the same as the speed, but we do have to be careful because very often exam questions will ask you to make the distinction between these two. So we do need to know the difference. Similarly with distance and displacement. So distance and displacement sometimes are exactly the same value and sometimes they're totally different. So d for distance and s for displacement. Now you might have come across this before. It does cause a bit of confusion. So in this context, s is not seconds and s is not speed, s is displacement. So we can rewrite our GCSE formula, speed is distance over time, to our A-level formula, velocity is displacement over time. So v equals s over t. So I could represent motion on a displacement time graph with s on the y-axis and t on the x-axis. And if I was to work out the gradient of this, if I have a straight line or indeed the instantaneous gradient, then I would get the velocity. Because of this expression here, because v equals s over t, then the gradient is s, y step, divided by t, the x step. So the gradient of a displacement time graph is the velocity. And if we were to get the correct full definition of velocity, we would say velocity is the rate of change of displacement, and we could say per unit time, but certainly the rate of change of displacement. Right, the second formula that you need to know, and hopefully you've seen before, is that for acceleration. So as we can see, acceleration is the change in velocity or speed, but really velocity, divided by time, and that will be given by this formula, a equals v minus u over t. So again, hopefully you've seen this before. V is the final velocity and u is the initial velocity, so v minus u will give us change in velocity, and then we divide that by time, and that will give us the rate of change of velocity. So we could write this as delta v over delta t, or v minus u over t. But this is a really, really important formula. And if we were to plot velocity against time, and if we had a straight line through the origin, then we would have a constant gradient, and here the gradient is equal to the acceleration. And the reason why is if I was to work out the gradient, I would have the vertical, that's the y, which is velocity, divided by the x, which is t. I would have the change in velocity divided by the change in time, which is acceleration. So really important, the gradient of a velocity time graph represents the acceleration. Also, I could work out the area underneath the graph. So in this case, it's a triangle. I could work out half times base times height. And that would give me the distance traveled, or even better, the displacement. But again, sometimes distance and displacement will be the same value. And the reason why is because of our previous formula, s is equal to v times t. So working out the area of this shape, I have to multiply velocity and time together, which will give me the displacement. Okay, let's look at a few worked examples. So if I wanted to draw this journey here on a displacement time graph, that's an ST graph, this is what it would look like. Constant velocity followed by stationary, then returning back to the start position with a greater velocity than the initial velocity. Okay, so we have a constant gradient here, which means a constant rate of change of displacement, which means a constant velocity. And then we have a section where the displacement does not change, so we're basically stopped, we're not moving, even though time is increasing. And then we have a negative gradient. So a negative gradient means we've changed direction. We have a negative velocity. We're going back to the start position, which makes sense on this graph because we started at 0 displacement and we end up back at 0. So we're right back at the start position. Also, I could look at the magnitude of the rate of change of displacement. That is the size of the gradient. We have a larger gradient, which means we have a larger magnitude of velocity. Right, what about if we have acceleration? How do we draw that? So we can see here, so this is distance time, it could be displacement time, it wouldn't make a difference in this case. We can see that the gradient is increasing, the line is getting steeper. So we always need to go back to what do we mean by the gradient. The gradient of a displacement, or in this case distance time graph, represents the velocity. If that is increasing, that means the velocity is increasing. Now we've got to be a bit careful here. If I want to work out the instantaneous speed or velocity, if I just do the total distance divided by the total time, which often students do, I will get the average velocity overall. So that won't be correct. So let's say if I want to work out the velocity at a particular point, let's say at 5 seconds, what I would need to do is to get a ruler and to draw a straight line at a tangent as best I can at that point, and then work out the gradient of that line. So you might get a question like this at A-level physics, and probably you wouldn't have seen this at GCSE. It's a little bit more difficult. To find the instantaneous speed, that is the speed or the velocity at a particular point, we need to draw the tangent. So what we're doing is working out the instantaneous rate of change of displacement, or delta S over delta T. Let's have a look at a simple worked example for acceleration. So this is a nice, easy GCSE example here. If we accelerate from an initial velocity of 10 meters per second to a final velocity of 30 meters per second in 2 seconds, what is the acceleration? So we can use our formula, the one from GCSE, A equals V minus U over T. So my final velocity is 30. Take away the initial velocity, which is 10. 30 minus 10 gives me 20, divided by the time taken would be 10 meters per second squared. So take a note of the units here. Different to velocity, that was ms to the minus 1. That was meters every second. Meters per second squared, what that means is every second the velocity is increasing by 10 meters per second. So we could think of this as 10 meters per second per second. So that s to the minus 2 means we're dividing by s squared. Also, we need to be familiar with velocity time graphs. So if I wanted to draw the VT graph for this journey, constant acceleration, then constant velocity, then increasing deceleration. Right, let's unpick this. So the first one should be straightforward. Constant acceleration, we have a constant gradient. The velocity is increasing by the same amount every second. We have a straight line. If I have a horizontal line, that means constant velocity. So we always have to check what the axes are. If this was displacement, that would mean we're stationary. But this is velocity time, so this is constant velocity. And then the final section says increasing deceleration. Okay, what's going on here? So we've got a negative slope, which means we're slowing down, and our final velocity is 0. That does not mean we're back at the start point, which it would do if this was a displacement time graph. And it says it's increasing deceleration. So we can see at the start, the gradient is relatively low. So we're slowing down, but our acceleration is not that big. But as it gets steeper, then our rate of change of acceleration, or deceleration in this case, is increasing. So our rate of change of velocity is increasing and we're slowing down more quickly, which means we have this larger gradient. Right, our final worked example. So if we have a velocity time graph, a VT graph, then I can work out various things from it. If we need to work out the acceleration between 0 and 4 seconds, then I could do this in two ways. I could either work out the gradient, which would be 20 minus 0, 20, divided by 4, or, which would give me exactly the same answer, I could use A equals V minus U over T. So V is 20, take away U of 0, 20 minus 0, divided by T, which is 4, I get 5 meters per second squared. So once again, 5 meters per second every second would be the change in my velocity. To work out the total displacement, or distance, but displacement is better, is how far we've travelled. I need to find the area underneath this line. So I could work out the area of the triangle. That would give me the distance travelled in the first 4 seconds. And then I could work out the area of the rectangle, the distance travelled in the next 4 seconds. Alternatively, you could work out the area of the trapezium, which might be simpler. Generally speaking, students just work out the 2 sections and add the 2 together. So half times base times height, half times 4 times 20 gives me the area of the triangle, which is 40. And then 20 times by 4, watch out for this, 8 minus 4 will give me 80. Add the 2 together will give me 120. Right, so what we've looked at is mainly GCSE ideas here. There shouldn't be anything particularly new. Maybe the definitions are new, which are important, but these are the fundamental ideas. So you must know all these ideas before we progress onto the new A-level content. Right, so what's next? So you can see the next video in this series on YouTube, which is on equations and motion, SUVAT. If you want more detailed lessons and tuition, you can go to payhip.com, grade A physics. And we've got structured lessons, there's practice questions and exam questions with work solutions. There are quizzes to make sure your understanding is up to speed. There's exam tips, and there's also tracking of your progress through each of the lessons. So check those out and see you later.